Suppose you conduct a random sample of 36 Boston men and find a sample mean weight of 198 pounds. Test the claim that the mean weight of men in Boston is 185 pounds. Given a population standard deviation of 40 pounds, use a 5% level of significance and the p-value approach. Describe the meaning of type 1 and type 2 errors. So first we have a hypothesis test, so we ought to do is right away write what the null and alternative hypotheses are. So the null hypothesis is that the mean weight is equal to 185 pounds. And it says in the problem to test the claim the mean weight in Boston is 185 pounds. So it doesn't say less than or greater than or is at least, so I'm thinking this is a two-tailed test, so the alternative is that the mean weight does not equal 185 pounds. Our level of significance, alpha, we're told to use is 0.05. So what we have to do now is look up the value for the test statistic. So in this problem, we're given the population standard deviation, which is important. So when we go to our formula sheet and we look up sample test statistics, then what we do is say, okay, since sigma is known, we know we're going to be dealing with z. If sigma was unknown, then we would have to use the value of t. Okay, so we need z, our test statistic, to be x bar minus mean divided by standard deviation over root n. Let's copy this down, and we actually have each one of these pieces. We can find the p-value, and then we can, get our answer and make our determination. So, test statistic equals z, since population standard deviation is known, and it's x bar minus mu over sigma over root n. Plug in all these values in. We have 198 from our sample minus our population mean, which is 185. We divide it by 40 over the square root of n. And how big was our sample? It was 36. So if we go to our calculator, what we have to do is carefully enter this in. What I do is I subtract first, and then I get the bottom second. If you just enter in 198 minus 185 and just do these one at a time, it sometimes doesn't work out. So do the top all together, then do the bottom all together, and then divide. When I do this on my calculator, I come up with a z value of 1.95. Now, what we have to do is find the probability of getting a z value that's extreme. The p-value, since we have a two-tailed test, is going to be equal to not just the probability that z is beyond or greater than or equal to 1.95, but because it's a two-tailed test, it's twice that. So we always have to double that probability. Let's look up 1.95 on our z table and see what probability we find. So for 1.9, this is 1.90, 1, 2, 3, 4. Let's see if this is right. 5. Yep. We get 0.9744. Now remember, whenever you look up a value on the t-table, or the z-table, excuse me, it always gives you the left tail. Since we're looking for the probability it's to the right, we're going to have to use the complement rule. So we're going to take 1 minus 0.9744. And again, because it's a two-tailed test, we double it. Doing that, we get a p-value of 0.0512. Conclusion? since our p-value in comparison to our significance level is greater than alpha, we don't reject H0. We only reject the null hypothesis when the p-value is less than alpha. In other words, when the probability of the sample that we did is really small, do we reject the null hypothesis, right? It's intuitively usually pretty clear, right? The p-value, if it's small, if it's really unlikely to get a sample that you did, then you say, oh, well, the original hypothesis has got to be wrong. In this case, the p-value is greater than alpha, so we don't reject. And what's the meaning of a type 1 error? It's that type 1 error is type 1 error would just mean we reject H0 when H0 is true. And a type 2 error is when we don't reject H0 when H0 is false. So in this problem, for example, since we didn't reject H0, there's actually the possibility for a type 2 error.